there are 27 confirmed moons of Uranus. That is significantly less than the number of confirmed moons that Jupiter and Saturn has, which is around 80 for both of them. But it is more than the number of confirmed moons that Neptune has, which is 14. Uranus has 5 major spherical moons, which is more than the number of major spherical moons that Jupiter and Neptune has, but it is less than the number of major spherical moons that Saturn has. So despite Uranus having a pretty big number of spherical moons, it is fair to say that there isn't a lot of talk going on about them. So far there was only one big visit to Uranus, and that was by Voyager 2 in 1986. It discovered that Uranus has a magnetic field stronger than that of Saturn, discovered 10 additional moons, and captured some images of its major moons up close. After that, it was on its way. Meanwhile, Saturn and Jupiter got way more visits, and they got their spacecrafts, which were specifically on a mission to be constantly around them and to observe their moons as well. For Jupiter, that is the Galileo spacecraft, and for Saturn, it is the Cassini spacecraft. Because of them both, and other spacecrafts that passed to them, relatively high-quality images of their moons were captured. But for Uranus, there were no such missions that were specifically centered around Uranus and its moons, although there are currently some very vague plans for such a thing to happen. Still, there is absolutely no certainty whatsoever that something will be done regarding that in the near future. There wasn't any date established as to when will that take place, and there are no indications that there are any big workings on such a project. The most significant reason that it didn't happen already is simply because Voyager 2 got enough images of Uranus's moons so that it can be concluded that there aren't extremely odd features that exist on them except for the moon Miranda. Of course, plenty of the surface area of the moons wasn't captured in any useful detail, so we don't really know certainly as to what is there. But likely there isn't anything there that is significantly different and odd in some regard compared to the surface area that was captured with some significant detail. For every major moon of Uranus, only between 30 to 50% of the surface was imaged in good quality that allows for geological mapping, meaning that it is still possible that some very significant in size geological features were not captured. And all of these major moons of Uranus are somewhat similar to each other. All of them have a pretty similar composition as a whole. Because of their density, we know that they are all roughly 50% ice and 50% rock, with slight variations, some being a bit rockier or icier than others. Most of their surfaces are very icy and do contain water ice. This all suggests that they formed in the same region around Uranus out of the same material. They also all on the surface possess 3 geological features to a differing extent. Those are craters, canyons, and slopes. None of them also have any significant atmospheres, with the possible exception of Titania, where it is almost certainly, if it exists, extremely thin. Now let's compare that. Saturn has Titan, which has a thick atmosphere and the lakes of methane and ethane. Iapetus with its contrasting sides and a huge ridge going along the equator. Enceladus has a subsurface water ocean that is promising for life forms. Jupiter has Europa, which is essentially like a bigger Enceladus. Io, the most volcanically active world in the solar system. Ganymede, the largest moon in the solar system. So clearly the competition for Uranus is very tough, and naturally because of those moons of Jupiter and Saturn, they attract way more attention, which in turn leads to more missions being conducted there. But that is also at the same time making Uranus's moons to be largely forgotten. Still, despite them not being super exciting, in this video I'm going to examine them and find interesting things regarding them, as there are still plenty of things there to be talked about. This is the view of their orbits around Uranus seen from the top. From this position, all of the orbits seem to be very normal. But if we look at their orbits from the side, we can see an anomaly in one orbit. That is the orbit of the moon Miranda. It is visibly tilted, while the orbits of the rest of the major moons are positioned at roughly the same angle. They are orbiting around the equatorial plane of Uranus. This is also the case for the smaller non-major moons of Uranus that are orbiting it closely. Now, the orbit of Miranda is not extremely tilted, but definitely is to a good enough degree for it to be puzzling. especially because it is the closest major moon to Uranus. In order to understand as to why this is puzzling, we have to take a look at the orbits of the moons of Jupiter and Saturn. What is clearly noticeable in the orbits of the moons of Jupiter is that the moons that are orbiting it closely are all positioned at the same angle. They are going around the equatorial plane of Jupiter, and that also applies for smaller, non-major moons. But if we look at the orbits of the moons that are far away from Jupiter, they start to get really wonky. They are extremely tilted. The same applies for the orbits of the moons of Saturn. The ones that are close to Saturn all orbited roughly around the equatorial plane of Saturn. The only anomaly is the fact that the orbit of the major moon Iapetus is significantly tilted. That is the furthest major moon of Saturn. And the further away we get from Saturn, we can clearly see that the orbits of the further moons start to become extremely tilted. The same also applies for the moons of Uranus. The further the moons are from Uranus, that is, the object that they are orbiting, the more they exhibit tilted orbits. But Miranda has a visible tilt despite being so close and despite being a major moon. It deviates significantly from that norm, which is why its orbit is so puzzling. It also doesn't have a retrograde orbit, meaning that Miranda wasn't captured by Uranus at a later date after it formed in a region far away from it. So it doesn't have an inclined orbit because it was captured, because it almost certainly wasn't captured by Uranus. Now, the tilts of the moons are generally more significant the more significant the distance is between the object they are orbiting. But what is also a significant predictor of an extreme tilt is a retrograde orbit. Retrograde orbit means that the object is orbiting in the opposite direction of the rotational motion of the object it is orbiting. Now, one of the reasons that strongly suggests that the moons which have retrograde orbits are captured is the moon Triton, which has a similar composition to Pluto, meaning that it likely formed in the region that Pluto did out of the same material, and after that it was likely ejected from that region and it got captured by Neptune. And it has a retrograde orbit, and obviously with that an extremely inclined orbit. So that suggests strongly that when an object has a retrograde orbit, it was captured by that object that it is orbiting at a later point after it formed in a region significantly far away from it. Still, all of the orbits of the major moons of Uranus relative to the equator of the Sun are extremely tilted. They are parallel to the rotational axial tilt of Uranus, and they are all roughly orbiting around the equatorial plane of Uranus. And since the axial tilt of Uranus is around 98 degrees, that means that its equator and the orbits of its major moons are facing the equatorial plane of the Sun sideways. The tilt, plus the fact that Uranus needs 84 years to complete an orbit around the Sun, causes for Uranus to have extreme seasons that last extremely long, and is why both poles of Uranus in different periods experience a 42-year-long daylight period and 42-year-long night period. In comparison, the axial tilt of the Earth is about 23 degrees. And because of that, there are seasons on Earth. And since the orbit around the Sun takes the Earth 1 year, both poles on Earth in different periods experience a 6-month-long daylight period and a 6-month-long night period. Now, because the major moons of Uranus also share the axial tilt of Uranus and need the same amount of time to go around the Sun, since they are with Uranus, they also have extremely long seasonal periods, and their poles in different periods, like Uranus's poles, experience a 42-year-long daylight period and a 42-year-long night period. But what is also interesting is that because they are rotating around their axes nearly sideways relative to the equator of the Sun, around their equators, the Sun would follow a circular path in the sky. It doesn't follow a nearly straight line from the position of their equators, like the Sun does from around the equator of the Earth. Now, the reason as to why Uranus has this extreme axial tilt isn't known certainly, but it's possible that it is there because at some point in the past it got hit by a very large object, and that tilted Uranus to this current extent. Now, all of these major moons have an average surface temperature of about -200 degrees Celsius, which is simply because Uranus is extremely far away from the Sun. The moons are receiving very little sunlight, and they can't get significantly warmed up because of that. Uranus is on average around 3 billion kilometers away from the Sun. That is 20 times longer than the distance between the Earth and the Sun. So Uranus and its moons are receiving roughly 400 times less sunlight than the Earth does. Still, the visibility of each major moon of Uranus differs as their surfaces reflect a different amount of light because they have a bit of variety in what they consist of on the surface, which creates a difference in the amount of light that they reflect. This also creates slightly different average surface temperatures. For example, the brightest, that is the most reflective moon, which is Ariel, has an average surface temperature of minus 213 degrees Celsius, while the darkest, that is the least reflective moon, which is Umbriel, has an average surface temperature of about minus 198 degrees Celsius. So Umbriel on average is by 15 degrees Celsius hotter on the surface. That is because it is absorbing more light and because of that more heat, which causes for a slightly higher surface temperature, while Ariel is more reflective than Umbriel, so it doesn't trap as much heat. Now, the orbital period from the innermost to the outermost major moon increases. That is the time that it takes for the object to complete a full orbit around the object it is orbiting. For Miranda, it's a day and a half. For Ariel, it's 2.5 days. For Umbriel, it's 4 days. For Titania, it's 8.7 days. And for Oberon, it's 13.5 days. They are all also tidally locked, meaning they need the same amount of time to complete an orbit around Uranus as they do to complete a rotation around their axis, which is also why all of them have one side that is always facing Uranus and the other one that is always facing away from Uranus. The closest major moon, Miranda, is 130,000 kilometers away from Uranus, which is 2.5 times closer to Uranus than the moon is from Earth. And the farthest major moon, Oberon, is 580,000 kilometers away from Uranus, which is 1.6 times greater than the distance of the moon from Earth. But considering that Uranus has a diameter of 51,000 kilometers, which is 15 times greater than the diameter of the moon, Uranus would appear from the surfaces of all of its major moons as many times bigger than the moon does from Earth. From Miranda, the closest major moon, Uranus would appear around 45 times bigger than the moon does from Earth. From Oberon, the farthest major moon, Uranus would appear around 10 times bigger than the moon does from Earth. What is sort of interesting about these major moons is that Ariel and Umbriel share an almost exactly the same size and they are neighbors, meaning they are next to each other. And so do Titania and Oberon. They share an almost exactly the same size and are next to each other as well. The only odd one out of them here, which doesn't have its twin in terms of size, is Miranda. Now, the surface gravity of Miranda is extremely low because of its low mass. It is 120 times weaker than the surface gravity of Earth. Ariel's is 36 times weaker than Earth's, Umbriel's is 49 times weaker, Titania's is 26 times weaker, and Oberon's is 28 times weaker. So clearly we can see that even the largest and most massive moon of them, which is Titania, largest moon of Uranus, still has a gravity that is 26 times weaker than that of Earth. So these are not particularly large and massive objects. Now let's take a closer look at Miranda. It is a tiny icy moon. Its diameter is 470 kilometers, which is tiny for a spherical moon. The only other spherical moon of a planet in the solar system that is also even smaller is Mimas, a moon of Saturn at 400 kilometers in diameter. So both of them have a diameter smaller than that of 4 Vesta, a huge asteroid. This diameter of Miranda, and because it's mostly spherical, also means that the surface area of Miranda is only 700,000 kilometers square, which is similar in area to Chile. Miranda is also highly icy, as the density that it has indicates that it is in the majority composed of water ice, around 60%, and 40% of rock. Now, it is safe to say that Miranda is the weirdest out of all the moons of Uranus, and not just because it has a puzzling tilted orbit and is tiny for a spherical moon, but also because its surface is pretty odd, as can be visibly seen in this image of it alone. There are huge canyons, hundreds of kilometers long and tens of kilometers wide. It's possible that they formed in the past when the liquid water beneath the surface of Miranda froze when heating because of tidal forces stopped. because water expands when it freezes. That caused an expansion of that water beneath the surface, and ultimately for huge cracks to appear on the surface above it as a result of that expansion of the material beneath the surface. There is the largest cliff specifically in the solar system exactly on Miranda, and it is likely a product of that type of geological activity. That is Verona Rupes at 20 kilometers in height. The slope is almost as tall as Olympus Mons, the tallest planetary mountain in the solar system. And perhaps the most odd geological feature of Miranda is the coronae that it has. On the observed part, there are 3 such coronae that are each stretching for 200 kilometers in length and can be around 15 kilometers deep in some parts. They are elongated fault scraps, pretty much long gaps, going along in an almost parallel fashion for hundreds of kilometers. Now, the surface of Miranda seems to be chopped up in certain parts, and some parts contain more craters indicating that they are older, while others, like the coronae, contain way less craters. This means that these parts of the surface are newer because there was more recent geological activity occurring there that largely erased the previous craters of that part of the surface. Now, despite the fact that some parts contain more craters than others, that is, that some parts experienced more geological activity or had geological activity at different periods in time, the overall appearance indicates that there were resurfacing events occurring globally on Miranda, because overall, there are, relatively speaking of course, not that many craters. The resurfacing events and the odd surface features are all essentially a result of geological activity which molded the surface in such odd ways. There was also plenty of heating going on Miranda at some point in the past, which is how one type of geological activity took place there, likely as a result of tidal forces due to the way that Miranda orbited Uranus and the way that the orbits of other major moons influenced Miranda, essentially pulling it in different directions and creating friction that created geological activity. Now, we don't even know what the entirety of the surface of Miranda looks like with good detail. Voyager 2 managed to capture only roughly 50% of the surface with a detail that allows for geological mapping. The rest remains somewhat of a mystery. But it is solely due to this moon that sparked at least some interest in sending a probe to Uranus exactly in order so that a much closer look could be taken at Miranda and so that the rest of the surface could be revealed to us. Now let's take a look at the second innermost moon of Uranus. With a diameter of 1,150 kilometers, it is the second smallest moon of Uranus. Still, that is double the diameter of Miranda, but that is still pretty small for a spherical moon. Our moon's diameter is 3 times greater, and inside the volume of the moon alone could fit 27 aerials. Now, in this image alone, there are several surface features that are notable, but the most significant one is the big number of huge canyons that are hundreds of kilometers long and tens of kilometers wide. They are also pretty smooth on the floor. There are also plenty of ridges and faults. Overall, there are not that many craters, and the observed surface, which is only 35%, is evenly cratered all throughout, which indicates that geological activity was happening globally at once and not in one place significantly more than the other. The most significant impact craters are very distinct, as there is a deposit of reflective material on them, and the most interesting part about them is that they are slightly blue in coloration, which is an anomaly. Now let's take a look at Umbriel, the third closest major moon. It is also the third largest moon, with a diameter of 1,170 kilometers, which is only roughly 20 kilometers wider than the diameter of Ariel, although it is quite a bit less massive than Ariel, so its surface gravity is significantly weaker than Ariel's. Its surface is noticeably the darkest compared to all other major moons of Uranus, and as visible in this image, it is also heavily cratered, much more so than Miranda and Ariel. Sadly, the image of Umbriel that was captured by Voyager 2 is not very good. The resolution is low and it is slightly blurry, making it hard to study its surface in depth, although there are still plenty of things that could be understood about it based on this image alone. So it is the second most heavily cratered out of all the major moons of Uranus. This indicates that there wasn't much geological activity going on here. So many craters stayed there and accumulated over time because of that. There might have been some geological activity, as there is a tiny number of canyons. But still, all this indicates that there was far less geological activity than on Ariel and Miranda, if there was even any at all. The surface also appears to be similar all throughout. The coloration, which is just slightly blue, is mostly even, with the exception of the crater Wunda. It is the only feature that really stands out in this image of Umbriel. It is a 130-kilometer long crater that has a very reflective material on its floor. Possibly this material is carbon dioxide ice, or it is something else that is a deposit from the object that hit that part. Next in the row we have Titania, the 8th largest moon in the solar system and the largest and most massive moon of Uranus. Its diameter is 1,575 kilometers. The moon, our moon, has a diameter that is slightly more than 2 times wider. The surface of Titania is not heavily cratered. It is actually quite similar in appearance to Ariel. It is almost like a bigger version of Ariel that is just not as bright. Now this also suggests that there was a significant geological activity occurring at one point in the past that erased a lot of the craters and created plenty of canyons and slopes. One canyon that stands out the most is Messina Chasmata. It is almost as long as the diameter of Titania, at 1,500 kilometers. Now water ice on the surface of these major moons of Uranus is extremely common, but carbon dioxide is not as much, especially in the quantities that are present on Titania. It's possible that it got there on the surface on Titania from outgassing from the interior, and there is enough of it so that during the summer season on Titania, when it reaches a certain temperature, that allows for a possibility for a lot of it to evaporate, enough so that an extremely thin layer of an atmosphere is created. If it exists, then it is very likely thinner than the atmosphere present on Pluto and Triton, and those 2 atmospheres are already extremely thin. There was even an opportunity to detect as to whether or not there is an atmosphere on Titania when it achieved a certain grade level of visibility, and there was no atmosphere detected at a range of around 20 and above nanobars, meaning that if an atmosphere exists on Titania, then it is at least several tens of millions of times weaker than the one on the Earth. The surface of Titania is also just very slightly red, and there is a difference between the 2 hemispheres in how much red coloration there is. And finally, we have Oberon, the farthest major moon of Uranus. It is also the 2nd largest. Its diameter is 1,520 kilometers, which is only by 50 kilometers smaller than Titania's. It is the 2nd darkest behind Umbriel, and it is the most heavily cratered, with a huge number of craters that go beyond 100 kilometers in diameter, suggesting that out of all the moons, there was the least amount of geological activity occurring, if any at all. It makes sense since it is the farthest away. There is the least amount of potential for tidal heating to occur in significant quantities so that it sparks up a significant geological activity, since there is the least amount of gravitational pull from other objects. Now, just like all other major moons of Uranus, Oberon also has canyons, and one in particular, called Mohr Chasma, is 500 kilometers long. Now generally, there isn't much standing out about this moon, besides the fact that it has the reddest surface out of all the major moons of Uranus. Now Titania and Oberon both have very slight red colorations. It is possible that they got that red material because it was deposited from the surface of another, smaller moon that is orbiting farther away. And it has weird dark patches occurring on only one half of the surface. We don't know as to what the composition of that dark material is. It's possible that these are deposits, or they could be a product of cryovolcanoes spewing that dark material, so that might indicate some very small geological activity. Or they could just be there as the object that hit those parts digged up a huge chunk of the icy surface and it revealed the dark material that was under. So that is pretty much it. As we can see, there are plenty of things that could be studied about these moons, despite them not being talked about, since other moons are pulling that general attention. Sending a probe to these major moons of Uranus so that they could be explored further definitely wouldn't be a waste. There is even that very slight possibility that some really huge geological feature could be on the not very well captured part of them.